Okay class, next topic is Kirchhoff's laws, that is the electrical measurements, Kirchhoff's laws. Before to discuss this, we have the Ohm's law, that is the fundamental law in electricity. Ohm's law is used to find the voltage or current for the simple circuit where we have only the one source of EMF, only one battery in the circuit. We use the Ohm's law. But when we have the complicated circuit, more than one source, more than one, we use the Kirchhoff's laws to explain that complicated circuits. These are of two types. First law, that is called junction rule. Junction rule means in a circuit at any point, if number of currents are there meeting at a point, the sum of these currents is 0. Means if we have this point in a circuit and the number of currents are passing through this is I1, this is I2, this is I3, this is I4 and this is I5, then the sum of these currents is 0. That is called the junction rule, and it is based upon the law that neither this point is the source of charge, not the charge accumulate there. ना तो ये चार्ज दे रहा, ना इथे चार्ज स्टोर हो रहे हैं. Or we can say that junction rule is based on the law of conservation of charge. And for this we have the sign conventions. The current towards the junction is positive and the current away from the junction is taken as a negative. Then I1, I2, I3 minus I4 minus I5, minus I3, I5 plus I5 is equal to 0. So this is called the junction rule. The currents which towards the junction is positive and the current away from the junction is considered as a negative. This is called first law. Second is loop rule. According to this rule, if we have a circuit and in that circuit, let's consider this, we have the circuit and in the circuit we have the two sources, this one E1, E2, the sources R1, R2, R3, R4, R5, and we have the name for this A, B, C, D. According to this rule, the sum of EMFs of the batteries, जिन्नियां भी बैटरियां सर्किट्स ने, उन्हां सारियां दी EMF दा summation, जिन्ने भी करंट particular resistance जो pass हो रहे हैं, like the current passing through R1, the product of that through R2, through R3, R4, R5, summation of that, they both are equal. And this is the loop rule, and this is also the second law, and it is depend upon the conservation of energy. This rule, conservation of charge, and very important question on which based the first law, on which first law of Kirchhoff rule is based, that is the junction rule, based on the conservation of charge, and the second is based on the conservation of energy. And the total summation of EMF is equal to the total summation of product of current and the resistance. Here we have these two sign conventions. Here we have again the sign conventions. The battery which deliver the current anti-clockwise, that is must be positive. Or if it deliver the current clockwise, it must be negative. And the current anti-clockwise is positive and clockwise is negative. Now how we can say that battery deliver the current? How the battery deliver the current? Battery, when we say conventional current, when we considering the conventional current, we say that this is the positive terminal and this is the negative terminal. Battery always deliver the current from positive to negative. Positive to negative. Never negative to positive. So when we draw the direction of current over this circuit, it is always from positive to negative. And if this positive to negative is in anti-clockwise, then EMF is positive, and if it is in clockwise, then EMF is negative. ਇਹਨੂੰ ਸਿੰਪਲ ਰੱਖਣ ਲਈ ਅਸੀਂ ਲੂਪ ਨੂੰ ਹੀ ਐਂਟੀ ਕਲੌਕਵਾਈਜ਼ ਕੰਸੀਡਰ ਕਰ ਲਾਂਗੇ ਵੀ ਕੰਸੀਡਰਿੰਗ like this is I1, this is I2, okay, and here we have the current I4, and here we have the current I5, and we have the current here, this is I2 and this is I3. Now we apply the junction rule and we apply this loop rule. How we apply this rule? Very important. The Kirchhoff rules are very important. Now this is the junction point at A. This is the junction point. I1 towards the junction. So it is positive. I4, I3. They leaving the junction. So it is equal to 0. We can also apply the junction rule at the point C. Here we also apply the junction rule. And for the loop rule, we consider this loop A, C, D, A, anti-clockwise. A, C, D, A. This is anti-clockwise. Now, when you consider the battery, the current diyan directions nahi dekhniyan jo draw hoiyan hoiyan, sirf battery dekhni hai. So considering this E1, this one. So this is anti-clockwise direction. Battery jo sadi loop di direction, so it is positive. Now what about this E2 battery in this loop? Not this. This is clockwise, so it is considered as a negative. And here I1, I3, I2, they are anti-clockwise. So I1 R1, this is I2 R2 plus I3 R3. We have this equation. Now for this next this anti-clockwise A, B, C, A. We have this battery and it deliver in this current in this loop in anti-clockwise. So it is positive. Now this is anti-clockwise and this is opposite to anti-clockwise means clockwise. So this is I4 R4, I5 R5 minus I3 R3. So we have these two equations, and by solving these equations we can calculate the value of current, the value of voltage, whatever be the question is asked in the numericals. So this is the Kirchhoff's laws, junction rule, loop rule. Junction rule, current formation total if sum of the current is 0, and for the loop rule the summation of EMF is equal to the summation of product of current and resistance. And what is the sign convention? Anti-clockwise. And for anti-clockwise they are considering positive, and for clockwise they are considering negative. And the next is Wheatstone Bridge. Wheatstone Bridge. This is quadrilateral form of the four resistances. They are connected in quadrilateral form. This is the 1, 2, and we can say that this and this. And here we have the battery, the source, key, and here we have the tapping key and the galvanometer G. R, X, P, Q, A, B, C, D. Total current I. When we close this, the current is I. We have this key. Here we have the tapping key, say K1, and say it is a K2. This is the quadrilateral form. Here we have the four resistances P, Q, R, X. These are the known resistances. In known ne ratio arms ne. This is unknown variable resistance box that you have seen in the laboratory, resistance box. and this is the unknown resistance which we have to calculate unknown resistance. Now when this current is delivered here, so I1 is here, I2 is here, and it is considered when it is balanced. Now how it is balanced? We know the P and Q, these are the known resistances, and the value of R. After closing this, the value of R is adjusted in such a way that when we press the K1, galvanometer shows zero deflection and the bridge is balanced. And when it is shows zero deflection, that means B and D are at the same potential, no current. Then I1, here I2, again the I current is leaving from the circuit. When it is in balanced form, we have P by Q is equal to R by X. This is the condition for balanced bridge. Now we know the value of P, Q because they are the known resistances. We adjust the value of R, that is also known to us. Then we calculate the value of X, that is called the unknown resistance. How we prove them? How we prove this condition, this balanced condition? Now let's say A, B, C, D. These are the potentials at the respective points. Then how we consider the potential? That is higher to lower potential current flow kar raha. A minus B, that is I1 P, current into resistance, again voltage. Then A minus D, I2 R. Then B minus C, that is equal to I1 Q. D minus C, that is equal to Ix. But for the balanced condition, potential of B is equal to potential of D. So we replace D with B. We replace D means A minus B is I2R, and here B minus C is I2X. Now A minus B I1P, A minus B I2R means I1P is I2R. Now B minus C I1Q, this become B minus C I2X, then I1Q I2X, and when we divide this, we got the balanced condition, that is P by Q is equal to R by X. So this is the proof of Wheatstone Bridge by the potentials. We can also prove this by using the Kirchhoff rules. Kirchhoff means junction rule and the loop rule. Then how we solve this? Kirchhoff rule. By using the Kirchhoff rule, how we prove this equation, this condition? For this we considering, let's I3 current here. This I1, I2, I3. Now here this become I1 minus I3, and here I2 plus I3. Then I is I1, I2. Then I1 plus I2. Or we can say that I2 is I minus I1. Now at point C. At C, what we got? I1 minus I3 plus I2 plus I3. These currents are meeting here. So here we have I1 plus I2. How we write the I2? How we write the I2? I1 plus I minus I1 cancel, and we get the I current here. I current, that is the current which enter the loop and after distributing again. Jinna current circuit enter karna, unna current leave karna. Now we apply the Kirchhoff rules. How we apply? We have the two loops. This one, A, D, anti-clockwise. A, D, B, A. A, D, B, A. Anti-clockwise. Battery koi nahi hai, to 0. That is, this is anti-clockwise. I2R minus I, say the resistance of galvanometer is G. So this is I3G, and this is minus I1P, that is equal to 0, because here in this loop we have a no source. This is the total source for the circuit. Now in this BD anti-clockwise, BDCB, we have again 0, then I3G plus I2 plus I3X minus I1 minus I3Q. Now for the balanced state, these 2 points must be at same potential, or we can say I3 equal to 0. Then these equations become I2R minus I1P equal to 0. Then I2X minus this I1 का 0 ही हो गया, I1Q equal to 0, or we can say I1P is equal to I2R or I1Q is equal to I2X. When we divide them, we again get the condition P by Q is equal to R by X. So this is the Kirchhoff's rules used to verify, used to drive the balanced bridge condition by applying the loop rule in the 2 loops. Now next is, we have the practical form of this Wheatstone bridge, that is called the slide wire bridge. In plus 2 course, we have the practicals, 3 or 4 practicals related to this slide wire bridge. Slide wire bridge is the practical form. It is also called the meter bridge. On this 1 meter length is required on this. There is a wooden slide wire bridge. It is based on this balanced Wheatstone bridge, P by Q equal to R by X. To find the unknown resistance, we use the slide wire bridge. And slide wire bridge is a meter bridge because 1 meter wire is required. It is a wooden block, एक wooden board आ, ਉਹਦੇ ਤੇ 1 मीटर ਦੀ ਤਾਰ ਲੱਗੀ ਹੋਈ ਹੈ. How we represent it? Very important. This is the 2 points of the wooden board. Here we have a 1 meter, this 1 meter wire. Along this we have the meter scale. ਇੱਥੇ meter scale ਆ 0 to 100 centimeter तक 1 meter. Here we have the copper strips in this form with a small gap. Copper strips with a small gap. Terminals to attach the terms. Here we apply the resistance box R, that is in Wheatstone bridge, and here we attach the unknown resistance X. Then this A point is connected with battery and key to control the circuit. Here in the middle of this we have the point D, and for this point we attach the galvanometer, and with galvanometer a jockey. This is pen shape, pen size, like this, like our finger. It slides over the wire. This wire, it slides, so it is also called slide wire bridge. And this jockey on this meter scale give the balance length. Where we get the balance length? When there is no current flow through the galvanometer. Means when the galvanometer is a device which is used to measure the current. We have the device ammeter, voltmeter, but the difference is galvanometer, meter point, scale point is middle. दोनों साइड ते है सुई डिफ्लेक्ट कर सकती है. So when we place here or here, the scale deflecting to show the connections. But when we get the balance point, this deflection of galvanometer must be 0. This is also called the null method. Then how we say null method? By giving the current from here, by adjusting the value of R. Same procedure. By adjusting the value of R, we slide the jockey over the slide wire bridge. And where the galvanometer shows the deflection 0, the bridge is balanced. This point. And this is length L, where the bridge is balanced. So what is here? 100 minus L, because it is 100 centimeter. So in this case, this P ratio proportional to L, and this Q is proportional to 100 minus L. So P by Q is L upon 100 minus L, as P by Q is R by X. So it means R by X is L upon 100 minus L, or X is 100 minus L R upon L, and we calculate the unknown resistance by measuring this balancing length, because this value is adjusted. This is the practical method how we calculate the unknown resistance. Right? And this balance point must be within 35 to 70 centimeter. ये 35 तो थले नहीं होना चाहिए और 70 सेंटीमीटर 30 भी ले लेने असी 30 to 70 सेंटीमीटर 30 तो थले और 70 तो ऊपर नहीं होना चाहिए. Why the balancing point is considering between these two limits? Because at the end corrections, these and these copper strips, they also have the resistance, and if we take the reading near there, their resistance is counted. So to avoid this, for the end correction, the balancing point should be within this limit. So this method is used to find the unknown, to compare the resistance also. How we compare? Firstly, we put here the resistance, any one resistance, say R1, we find by using this its balancing length, let it is L1. So how we write R1? 100 minus L1 R upon L1. Replace with another unknown, again find its resistance, that is L2 upon L2. And when we divide this R1 divided by R2, we are getting this value, that is equal to 100 minus L1 L2 upon 100 minus L2 L1, and we compare the two resistances. Again, the third one, we have to find the unknown temperature. This method is used to measure the balancing length. Then how we calculate the temperature? For that, we have the formula. In first chapter, we have the formula of resistance with the temperature. This formula, R naught 1 plus alpha theta. This is at 0 degree Celsius temperature coefficient, and this is the change in temperature or any temperature. This equation is written as R naught alpha theta. And if we have the 100 degree Celsius, then we again write it 100, 0, not 100. Means this is the resistance, this is unknown temperature, this is the resistance at 0 degree Celsius, this is the resistance at 100 degree Celsius. And if we divide these two, then this unknown temperature can be calculated by measuring these resistances. Then how we measuring these resistances? Again by using this formula, that is 100 minus L upon L, by knowing the unknown resistance. Here we can say it R dash. So firstly, when we want to R naught 0 degree, is unknown no 0 temperature te rakh lo, jiਵੇਂ ਕੋਈ ice ਦੇ ਵਿੱਚ immerse ਕਰ ਲਓ, then find the balancing length, and that is R naught. फिर ਉਹਨੂੰ 100 degree Celsius ਤੇ ਰੱਖ ਲਓ, then find R100 by using this formula. Then after we put that in the unknown liquid temperature and again find the resistance, that is R, and by using these values here we can calculate the unknown temperature. So this is slide wire bridge, and the next